Hi students, now we are going to explain the second example for the third application to establish the relationship among the physical quantities. The force F acting on a body moving in a circular path depends on three factors. One is mass of the body m, second is velocity of the body v, and the third is radius of the circular path. So the radius of the circular path can be taken as r. Now you look at this diagram. O is the center of the circle and a particle of mass m is revolving in the anti-clockwise circular path of radius r. Now in circular path the direction of the velocity is continuously changing. To find the direction of velocity, we have to draw a tangent. Okay, draw a tangent. So at every point, if you draw a tangent, means that will give you the direction of the velocity, where its magnitude is v. I will take its magnitude only. So these are the three factors. Okay, m, v, and r, on which the force depends on. So what is the force we are going to see? So for that I will take force F, the force, okay, F depends on, or force F, it is very clearly given depends on, okay, therefore I will write it depends on three factors, namely M, then V and R. By how much powers we don't know, okay. So I will take F is proportional to M raised to the power A, and F is proportional to the velocity v raised to the power b, and F is depending on the third factor, namely r raised to the power c. So combining all the three, I will write this force is proportional to m power a and v power b and r power c. As usual, this proportionality I am going to change into an equation, means I have to multiply by what? Proportionality constant, which is dimensionless. So this F is equal to a constant k into m power a, v power b into r power c, okay, into r power c, and this is the first equation, and here k is a dimensionless constant. It is a dimensionless constant. By experimental method, it can be found. And also it is found that the value of k is equal to 1. Okay, k is equal to 1. It is found that k is equal to 1. So in the final step, we are going to substitute k is equal to 1. Now we have to determine the values of a, b and c, is it not? So for that, what is the dimensions or dimensional formula of F? What is the dimensions of F? The force is mass into acceleration. So it is m power 1 into L t power minus 2. This is the expression, dimensional formula for the force. And the dimensional formula for the mass is capital M, and velocity is L t power minus 1, and radius is nothing but length. So the dimension is capital L. So in the first equation, there is one term, namely force, on the left hand side, and there are three terms, physical quantities, on the right hand side. I am going to substitute. So substituting the dimensions, dimensions, okay, the dimensions of each term, substituting dimensions in the first equation. So left hand side, what I have to write is what? This is m power 1, L power 1. So L power 1, t power minus 2. This is force. And k has no dimensions, is it not? K has no dimensions. So the right hand side, what are the terms leaving k? M is mass. So m is raised to the power a. So m power a, okay, into this velocity is L t power minus 1. So this is L t power minus 1 whole power b into the third term is radius. Radius is nothing but length. So it is L raised to the power c. Okay. Now this is equal to, the right side there is only one m term, So that is what? M raised to the power a into, I will find out how many L terms are there. So in the second and the third bracket there are L terms. In the second bracket L is raised to the power B. In the third term L is raised to the power C. So totally L is raised to the power B plus C. L is raised to the power B plus C. And there is one and only time factor in the middle term. There is no t factor in the first and the third terms. So t power minus 1 whole power b. So what is t raised to the power minus b? T is raised to the power minus b. So this is raised to the power minus b. Okay, now I am going to equate. So equating the powers. Okay, equating the powers of the terms m, L and T. I am going to equate the powers. So left side m is raised to the power 1, right side m is raised to the power a. So what must be the value of a equal to? Yes, a equal to 1. Direct, very simple. So I will be writing here now. Okay. So equating the powers of m, L and T on both sides, I find that a is equal to 1. So I will write first a is equal to 1. So one value we have found. After that you see here, this t power minus b is equal to t power minus 2. So t power minus b is equal to t power minus 2. Or minus b is equal to minus 2 means what is b equal to? B equal to 2. So I will write this is minus b is equal to minus 2. Therefore b is equal to 2. So this also we have got. B is equal to 2. Now equating t. Okay. B we have got. Next L power b plus c is equal to L power 1. So b plus c is equal to how much? 1. So b plus c is equal to 1. So 2 plus c is equal to 1. C is equal to 1 minus 2. Therefore c is equal to minus 1. C is equal to 1 minus 2. That is a minus 1. Okay, c is equal to minus 1. So we have got all the values. A is equal to 1, b is equal to 2 and c is equal to minus 1. K is already equal to 1, is it not? Dimensionless constant K is already equal to 1. So now substituting these values, okay, substituting in equation 1, okay. So substituting in equation 1, the values of A, B, C and K. So you look at the equation 1, F is equal to K into M power A, B power B and R power C. So I will write F is equal to m raised to the power a 1, okay, into v raised to the power b, that is 2, into r raised to the power c, that is minus 1. So r power minus 1 is going to the denominator. Therefore this force is equal to m v square by r. Such a force acting on a body revolving in a circular path is having a special name. What is the special name? That is called centripetal force. Very important. Centripetal force. Okay, students. So you remember this? Name of this force acting on this body revolving in a circle is called centripetal force. So I will again show a simple diagram for your understanding. So this is a circular path. So in the circular path now an object is revolving. Say for example, this is a satellite revolving around the earth. Okay, satellite revolving around the earth. So the force is acting towards the center. So this is the force, centripetal force. This will be always perpendicular to the direction of the velocity at any point. So at any point along its path, no, the centripetal force will be acting towards the center. Okay, along the radius. Centripetal means center seeking force towards the center, and it is always perpendicular to the direction of the velocity, and its expression is F is equal to mv square by r. I hope you must have understood, enjoyed, fine.